The twist drill is the most widely used tool in industry. The aircraft ejector seat is just one of the precision applications it can be called to work upon. Every day, many millions of holes are drilled in a variety of products, from cars and aircraft to machine tools and typewriters. To produce holes in all the different types of metals, twist drills are used singly or in multiple setups, and drill vertically, horizontally, or from any angle. Twist drill is a precision-made tool and deserves to be treated with care and forethought, as much care and forethought as the manufacturer has put into the making of it. The quality steel necessary for precision drill making is manufactured at Dormer's Napier Steel subsidiary, whose skills in steel making are as old as Sheffield steel itself. The latest production techniques are used to meet rigid metallurgical requirements. This electric furnace reaches a temperature of approximately 1500 degrees centigrade and produces a ton of high-speed steel at each cast. A sample drawn from the furnace during the melt is analysed on the polyvac before it is allowed to be used for forging. This guarantees the specification and renders chemical laboratory testing of the cast ingots obsolete. The high-speed steel bars are then sent to the Dormer drill factory, where they're critically examined and tested ultrasonically for flaws. This is how a flaw shows up on the oscilloscope. Any bar showing a defect is immediately rejected. Steel which meets these stringent requirements is then released for production. Every part of a drill has a specific function and has to be manufactured to extremely close tolerances. Obviously, the cutting is done by the drill point, and it is essential that each cutting lip should be at the same angle to the axis of the drill, and that they should be of equal length. This ensures each lip removes the same amount of material with a balanced cutting action. To allow the drill to feed into the work, there must be sufficient clearance behind the cutting lips. The accuracy of the chisel angle determines the accuracy of the hole. Too great an angle results in bell-mouthed holes. Too small an angle makes the drill ineffective. A correct angle ensures efficient entry into the work and minimizes peripheral wear. The flutes carry the swarf clear of the cutting edge and also allow the coolant to reach the point. The shank makes firm contact with the socket of the machine, and the contact provides the only source of drive, through friction. The tang on the shank is not intended to transmit the drive. It is only there for ejection purposes. There are something like 60 different operations in the making of a drill, from blanks, through butt welding, rough coning the point, turning, fluting and backing off, hardening, shot blasting, grinding, and bluing, to silver ring grinding. This sequence shows the production of taper shank drills. The steel bars are cut off at precisely the required length. Taper shank drills have a high-speed steel body which is flash butt welded to carbon steel for the shank. coffee lathes are used to turn the shank and the body simultaneously. The tang is produced by milling, as are the flutes and body relief. The flutes of the drill are specially shaped so that when the correct point angle is produced, the cutting lip forms a straight line. The taper shank drill is then heat treated in salt baths. Since the drill must be harder than the material it is to cut, yet not so brittle as to chip or break, heat treatment is a very important factor, and rigid standards are kept. Finally, the tools are finish ground to close tolerances by cylindrical grinding. Jobber drills are produced by a slightly different method. Dormer draw many miles of high-speed steel each year in the range of 0.75 millimeters to 15 millimeters in diameter. This is used for the production of all jobber drills. Carbide dies are used to control the very tight tolerances which are required. Once the high-speed steel blanks have been cropped off by a guillotine, they are induction heated and passed between revolving carbide dies to form the flutes. The jobber drills are then heat treated on this carousel. Certain sizes of jobber drill are also flute ground. As well as being finish ground by centerless grinding, jobber drills also have body clearance grinding before they too conform to the strict manufacturing tolerances. The most crucial part of any twist drill is the point. The accuracy of the holes and the efficiency of the drill depend on correct point grinding. Hundreds of thousands of drills are produced here every week, and they all leave the factory with perfectly ground points. Blue treatment is an additional thermal process to relieve any stresses produced in the grinding operation and impart a non-metallic surface to the drill. This reduces friction and absorbs lubricant, thus increasing drill life on ferrous metals. Most straight and taper shank drills have the distinctive Dormer silver ring patented marking method. A bright ring is ground on at the recess to highlight the roll mark of the drill size and our name. The position of the silver ring allows the markings to remain clear even when the shank becomes scored by the chuck claws, so you'll always know what size the drill is and who made it. A tool made with such care demands as much care from those who use it. Make sure you've got the right type of drill for the job in hand. The information handbook will tell you. Make sure that the taper shank of the drill and the socket are clean and free from burrs. Otherwise, the drill will not fit correctly and the tang will twist off or the drill will drop out. Don't ruin the drill before you even start work by using steel hammers or spanners. A mallet of wood or some other soft material such as hide or lead should be used. Make sure that the workpiece you are going to drill is rigidly held. If it bends or moves in any way, a strain is put on the drill which will reduce its efficiency and possibly break it. Keep the quill extension to the minimum. Select the correct speed and feed for the size of drill and the material. Direct an adequate supply of coolant to the cutting area, not halfway up the drill. And make sure, too, that you're using the correct lubricant. Above all, look after the point of the drill. Don't let it get too blunt. You'll only have to grind more off to get it sharp again. A blunt drill will warn you itself. Don't ignore it. A blunt drill will produce a poor finish and out-of-tolerance holes. A machine ground point is always more accurate and therefore more efficient than one ground by hand. Correct clearance is provided on all dormer drill sharpening machines. Each flank of the drill is ground from the same location point. Therefore, both flanks of the drill are identical. This simple model 108 point grinder is designed to provide a reliable general-purpose machine for the rapid and accurate regrinding of twist drills by unskilled labor. Other dormer point grinding machines include this model 100 semi-automatic. It's able to produce a correctly formed point on all sizes and types of drill above 8 millimeters automatically. The design makes possible the fastest and simplest changeover, one type of drill to another and from one length to another. The increasing use of numerically controlled drilling machines has created a demand for a more accurate performance from the twist drill. These machines position the drill with precise control, but the accuracy of the holes produced depends on the ability of the drill point to center itself and drill true to the spindle setting. Designed to meet this particular need is the Model 84 center point grinder, which produces a unique design of drill point. This point is remarkable in that it cuts not only along the two lips, but also at the chisel, minimizing drill wander and oversized holes. This eliminates the need for punching, center drilling, or pilot drilling to ensure accurate holes in the exact preset location. The core, or web of a drill, increases in thickness towards the shank to give the drill rigidity. Therefore, as the drill is shortened by repetitive sharpening, it becomes necessary to thin the web at the point. This operation is better performed mechanically, as it is essential that it is correctly formed and equally balanced about the drill axis. Correct clearance, point angles, chisel angle, and other features of drill point geometry can be checked accurately on the dormer goniometer drill inspection unit. The economics of drilling, the actual cost per hole, depend entirely on the quality of twist drill and the care with which it is used and maintained. Sheffield Twist Drill and Steel Company Limited have been making quality twist drills since 1913 and produce several million of these tools each month. They are available in more than 120 countries throughout the world from dormer engineering distributors. And whatever the need of industry, there is a dormer drill to suit it. Whether you need a specialized drill or an all-purpose tool to do many different routine operations, you will find it here. To meet the exacting demands of modern industry, many millions of dormer drills are in constant use throughout the world. Drilling side body panels for the national bus. typewriter carriages and assemblies. Machine tool castings. Titanium components for Concorde. Engine cylinder blocks for the automotive industry. Engine crankshafts of various types. Aircraft ejector seats. All right, you can come down now.